let's talk about nonlinear inequalities. Now, we know how to solve an inequality. Whether they tell us to or not, we should always graph. And they're talking nonlinear, which means, I may have a second degree polynomial. And I know how to solve that. I can either factor it or quadratic formula it. But the question is, how do I go from solving by the quadratic formula or factoring into graphing mode? What's the connecting dot? So here's the thing. Let's take a look at this particular problem. And if you notice, I have two parentheses multiplied together, and on this side is a 0. So it kind of looks like something's been factored, right? Now, something we need to understand though, when we factored, there wasn't an inequality. It was actually equal to 0, right? So here's the deal. When you have to solve these inequalities, what you're first solving, whether this equal to sign is here or not, you are first solving the equality. You are solving it with it being equal to 0 always, because that is how we have learned to solve a second degree equation. That's how we learn to solve something that's already been factored. It has to be equal to 0. This inequality was never around when we first learned how to do it. So now that I have this equation set up, this is very easy to solve. I set each parenthesis equal to 0, and I solve for x. So, whoops, forgot the equal 0. So easy peasy, x equals 5 here, and x equals a negative 1/2. Agreed? Now, the question is, how do I go from solving by factoring, because this looks like it was factored, how do I go from this into graphing mode? Because I don't see the connection. So here's what we need to understand. If we're going to graph, that means there's an x and a y. Agreed? There's an x-axis and a y-axis. So here's the deal. I clearly see x. What I don't see is y. But somewhere in this original inequality, in this original problem, was a y value. Now, you may not see it, but it's there. Do you notice? This side would have been where the y was, wouldn't have been. This would have been your y value, correct? So now let's think about it. I just solved for x when y equals 0. Y is equal to 0, which means what do these x values actually represent? Some of you got it. They represent x-intercepts. When y is equal to 0, you are finding x-intercepts. And that means you have found two x-intercepts, 5, 0 and negative 1/2, 0. Because you have x-intercepts, now it makes perfect sense for me to graph. And the only numbers I really care about on the x-axis are negative 1/2 and 5. Good? Now, by the way, I could also put the y-axis in here, but trust me, it's going to be easier for it not to be in here. Now, let's take a look at this. I have 3 intervals, and I have to figure out which interval is going to make this inequality true. So, the best way to do it is to actually take a number from this interval. So if I take a number between negative infinity and negative 1/2, for instance, I'm going to take negative 1, and if I plug it in for my x over here, the question is, will it make this left side less than or equal to 0? So check it out. Will it? negative 1 minus 5. Good, that would be negative 6. And I am just going to write it up here. And what's negative 2 times, 2 times negative 1? Good, that's negative 1, right? That's negative 2 plus 1 gives me negative 1. Well, that multiplies to a positive 6, doesn't it? This is a positive answer, isn't it? Is this less than or equal to 0? Nope. This interval doesn't work for us. Okay, I have 2 more intervals to try, so let's check it out. We're going to do the exact same thing. We're going to take a number in between negative 1/2 and 5. What's the easiest number? Good, 0. So I'm now going to take 0 and I'm going to substitute 0 into this original problem. And I am going to see if my result is less than or equal to 0. So, plugging in 0, plugging in 0. What's 0 minus 5? Good, negative 5. What's 2 times 0? Yep, 0 plus the 1. Good, gives me 1. I end up with negative 5. Is negative 5 less than or equal to 0? Yes, it certainly is. So this interval is working for us. Last interval, I'm going to choose a 6. And now we're going to plug in the 6. So, you do your work, I'll do mine. Hopefully we end up with the same answer. So I'm plugging in 6 and 6. What's 6 minus 5? Good, 1. 2 times 6, 12 plus 1. Yeah, that's 13. Is 13 less than or equal to 0? Nope, it is not. So I only have one interval that actually has worked for me. The interval that has worked for me is going from a negative 1/2 to a positive 5. Are you with me? Now, I've got to decide, do I put brackets around these or do I put parentheses around these numbers? Look back at your inequality. The inequality has this equal to sign, doesn't it? So does that mean brackets or parentheses? Yeah, that means brackets. So, in this particular case, the x values, they're going to make this left side less than or equal to 0 are anywhere from a negative 1/2 to a positive 5. Cool? Makes sense? Okay, hang in there. Got a few more examples. Okay, so let's look at this second problem. They're asking us to solve, and we are missing part of the problem. This is what we're being asked to solve. Now, here's the deal. I have a second degree equation, and the best ways to solve are either factoring or using the quadratic formula. Either way, when I first learned how to solve using those processes, they were equal to 0. There was never an inequality there. So, in order to solve this, you're not solving this inequality. You are first solving the equation. And now that I have this equation, I can either factor it or use the quadratic formula. So, I'm going with factoring because I notice both of them have an x in common. So I can factor out an x, also known as the GCF, greatest common factor. I'm factoring out that x. And now I'm noticing that this problem is like the last one. I have 2 parentheses. I have this x times this parenthesis. And I can set them each equal to 0 and finish solving. This one's already equal to 0, so we're good. This one, this x is already by itself, so we're good. This x I need to get by itself, add the 21, and divide by 10, right? Cool, loving it. Okay, nothing new. We were doing this in the last lecture and the lecture before, so this is nothing new. Now, remember, We need to find that dot that connects us from solving a quadratic into graphing mode. Remember, there's supposed to be not only an x here, but there's supposed to be a y. If I'm going to graph, there's got to be a y here. This is the y value. My y equals 0, which means you have actually found x-intercepts. One of them is 0, comma 0, and the second one is 21 over 10, comma 0. I have two x-intercepts, which will lead me straight into graphing because that's what an x-intercept does. We graph those. So my x-axis, negative infinity here, positive infinity here. Put the 0 and the 20 and 1 over 10. We always have to make sure we have numerical order. With me? Okay. Now, I've got 3 intervals, and I've got to figure out which of these 3 intervals is going to work for us. Which of these 3 intervals will make this quadratic greater than or equal to 0? So, just like the last one, I'm going to choose some numbers. So in this first interval, I'm going to choose -1, and I'm going to plug it into this original problem. What's -1 squared? Good, positive 1. Times 10? Good, positive 10. What's this -21 times this -1? Good, it's a positive 21. If I add these two numbers, will they be greater than or equal to 0? The answer is yes. Okay, so this first interval, we're good with. That's one of my answers. The second interval, what? 21 over 10 is a little bit over 2, isn't it? So I think I'll choose the number 1. The number 1 is in between these two numbers. So plug in 1. 1 squared? Good. 1 squared is 1. 1 times 10 is still 10. Good. -21 times a positive 1. Yeah. That's going to be a -1. 10 minus 21. Is that greater than or equal to 0? Nope. This one is not working for us. That's a definite no. All right, this last one. Yeah, that's a little over 2. So I'm going to choose 3. You know, I could have chose 10. I could have chose 100. I could have chose 1,000,000 if I wanted to. But I'm trying to keep things easy for myself. So let's check this out and see what we get when we plug in 3. What's 3 squared? Good, 9. What's 9 times 10? Yep, that's 90. Minus, what's 21 times 3? Good, 63. Is 90 minus 63 greater than or equal to 0? Yes, it is. So I'm noticing I have two intervals that work for us. One interval, this yes interval, starts at -infinity and ends at 0, doesn't it? The second yes interval starts at 21 over 10 and ends at infinity, doesn't it? Okay, what do you put on your infinities? Always parentheses. In this case, what do I put on the 0 and the 21 over 10? Yeah, because this is an equal to sign, I'm putting brackets on those. So here's the deal. These answers are actually mathematical sentences. So you're telling me your answer is in this interval. What's the conjunction? Yeah, some of you are going, what about that you thing? Yeah, that you thing is the word or. So my answers are in this interval or this interval. Cool? Does that make sense? Okay, loving it. Hang in there. Got another one coming up. Okay, so let's look at this third problem. Now, I have a second degree term, don't I? Which means I am either going to solve this by factoring or using the quadratic formula, right? But when you solve it, you need one side to be a 0, don't you? Okay, so we like x squared, or whichever variable is squared. We always like that to be positive, don't we? So that means I'm going to keep the x squared over here on the left. And I'm going to move that 8x over. And yes, I need to subtract it over. Now I've got one side equaling 0, don't I? Good. But again, here's the challenge. Whenever I solve using the quadratic formula or even factoring, it needs to be equal to 0. No inequality, it needs to be equal. So, just like we did on the last two problems, we are going to first solve with me. Looks familiar, doesn't it? Good. Do you notice there's an x in common? Excellent. So I'm going to take that x out, and I'm going to be left with this factoring. And again, you said each one equal to 0, and you solve. Gratefully, this one's already solved. I don't have to worry about it. The other one is going to equal 8. Did you get that? All right. Now, what are these two numbers representing? Yeah, these two numbers are your x-intercepts. Y is equal to 0 here. This is my y value still. So that means you found x-intercepts. One of them is 0, 0, and the other one is, good, 8, 0. And since these are x-intercepts, that means your next logical step is to, there you go, graph. You're getting the hang of it. Okay. Two x-intercepts. One was a 0, one was an 8. Remember, that's still a number line. Please make sure you write them in numerical order. And then I need to figure out which one of these three intervals is going to work for me. Agreed? Okay. So, I could choose -2, -5, negative, whatever I wanted. But I'm just going to keep it easy, and I'm just going to choose a -1. Now, you have a choice. You can plug it back into this problem right here and see if it's a true statement. Or you can actually plug it into here where you got the 0 on one side. The choice is actually yours, which one you want to plug it into. Me personally, I'm going to plug it into this one. So I'm just going to do my work down here. So I'm going to take -1. -1 squared is, good, 1. What's -8 times a -1? Good, +8. Is this greater than 0? Yes, it is. So this interval is working for me. The next interval. I can choose 1, I can choose 2, I can choose 7.5 if I want. But I'm going to make my life easy, and I'm going to choose a +1. So, a +1 squared, good, is 1. A -8 times a +1, good, that's a -8. Is that greater than 0? Nope. This one is not working. So, there goes that one. And then this one. Yeah, I'm just going to choose 9. I'm going to keep the number as small as I can. So, what's 9 squared? Excellent, 81. What's -8 times 9? Yeah, -72. Is that greater than 0? Yes, it is. So in this case, I have got two intervals that work for me again. The first yes interval starts at -infinity and goes to 0. The second yes interval starts at 8 and goes to infinity. What do you always put on your infinities? Good, parentheses. Now, you've got to figure out on the 0 and the 8, do you put parentheses or do you put brackets? Well, if I take a look at my inequality, either the original problem or the next line where I set it to 0, there is no equal to sign, which means I put parentheses around these guys because it means not equal to. And yes, I have to connect it with the or conjunction. Cool? Does this make sense? Okay, hang in there. Got another one for you. Okay, so let's look at this fourth problem. This problem looks very interesting, doesn't it? So I've got a third degree equation, or pardon me, a third degree inequality that I'm supposed to solve. Now, regardless, I have one choice to solve this, and that is factoring. Because we have solved third degree equations before by factoring. So remember, the first thing we're going to need to do is we're first going to have to solve it as an equation, not an inequality, an equation. So now we have to figure out, how do we solve this? Well, you know, how many terms do you have? You've got 4 terms, don't you? Remember when you started your factoring days? 4 terms meant you would group them. You would pair them up. So I am going to take the first pair, and then I'm going to take the second pair, and I'm going to ask myself, what's in common with these pairs? Well, I noticed the first pair, they both have a 4 in common, right? And they both have an x squared in common. So I am going to take out of the first pair a 4x squared, which will leave me, good, x, and then a positive 7. In the second pair, I'm noticing this first term is negative, so I know I'm going to factor out a negative. Now, what goes into 25 and 175? Good, 25. So in the second pair, I'm factoring out a negative 25. So when I factor that out, okay, I know some of you went to your calculators. Well, gratefully, a negative 25 divided by itself is 1, which leaves me just the x. A negative divided by a negative is, good, positive. And 25 goes into 175, good, 7 times. Okay, looking familiar? Yeah, you did these before. It may have been a while, but you've done these before. But I'm not done factoring because I still have a subtraction problem here. So I'm noticing that this x plus 7 is in common, so I can factor out the x plus 7, and I'll be left with 4x squared minus 25. Now the question is, are you done factoring? And the answer is no, because this second degree equation can still be factored, can't it? Yes, it can. So now you have to remember how to factor this parenthesis. And I know you remember, and I'm going to let you go figure out the work just in case you're like, wait, how do you do that again? Remember, it's a difference of squares, in case you're like, wait. That's right. Now am I done factoring? I certainly am. And I get to take each one of these and I get to set it equal to 0. And when you set each one equal to 0, you'll get a negative 7 from the first parenthesis. From that second parenthesis, you'll get a positive 5 halves. And from this last parenthesis, you'll get a negative 5 halves. And what are each of these x's considered? Yes, each of these x's are x-intercepts, because this was your y value. Good? Okay, and since I found x-intercepts, what do I get to do next? That's right, we get to graph. So, we have our negative and positive infinity, and I need to make sure I put these in numerical order. The negative 7 will come first, the negative 5 over 2 next, and the positive 5 over 2 last. Good? Now I've got 4 intervals to work with. Okay. And I have to do the same thing I did before. Take a number from each interval, plug it in, and see if it works. Now, this looks like fun. So, I am going to choose a negative 8 in this interval, because that's between negative 7 and negative infinity. And you know, this is a lot of work to punch in. I'm going to need my calculator for that. So I'm going to choose to look at this a little bit differently. Bear with me a second. I'm going to choose to look at this just a little bit differently. You know, we just factored this third degree polynomial, didn't we? And when we factored it, this third degree polynomial factored to x plus 7 times the parenthesis of 2x minus 5 times the parenthesis of 2x plus 5. And that would still be less than 0. Are you with me? So, I could either take the negative 8 and plug it into this third degree polynomial, or I could take it and plug it into its factored form. And maybe if I plug it into the factored form, it might just be a little bit easier to manage, a little bit easier to work with. Are you with me? So, I'm going to give myself some board space here. And I know you already have your papers, so you guys are good to go. And we're going to start figuring this out. I'm going to take negative 8 and plug it in. And when I take the negative 8 and I plug it into x plus 7, what do you get? Yeah, you get a negative 1 here when you plug in the negative 8, don't you? When I plug negative 8 into here, what do I get? I get a negative number, don't I? I don't know what the number is, and I'm going to be honest, I don't care what the number is. All I know is that this second parenthesis will be a negative number. Okay, if I plug the negative 8 to here, what will I get? A positive or negative? I'll get another negative answer. Now, here's the question. When I multiply these three negatives, will it be a number less than 0? Well, negative times negative is positive. Positive times negative is negative. And negative is certainly less than 0. So yeah, this interval works for us. Good? Okay, this next interval, I think I'll choose a negative 6. And again, we're going to plug it in to all three of these, and we're going to see if it works or not. So when I take a negative 6 and plug it into here, yeah, that'll be a positive answer. If I take a negative 6 and plug it into here, yeah, that'll be a negative answer, won't it? I don't really know what the number is, and I don't care what the number really is. All I know is it's negative. When I take the negative 6 and plug it into here, what do I get? Yeah, I'll get another negative answer. Whoops, sorry. I did not mean to put a negative 1 there. I just meant to put a negative. My apologies. Okay, so positive times negative, negative times another negative is positive. Is a positive number less than 0? Nope. This one's not working. Okay, now I'm going to choose a number between negative 5 halves and 5 halves. Positive 5 halves. Yeah, 0 falls in there, and I like 0. 0 is an easy number to work with. Okay, so plug 0 into here. Yep, that'll be positive. Plug 0 into here. That'll be negative. 0 into here will be positive. Will this be less than 0 when I multiply a positive, a negative, and a positive? Yeah, it'll be negative. This one works. And last but not least, what is this? A little over 2, right? So I'm going to plug in a 3. Okay, one more time. Let's see what we get. We plug in a 3. That'll be a positive. That'll be a positive. That'll be a positive. And that's definitely not less than 0. So in this case, I have two intervals that work. Two yeses. One of my yeses, my first yes, is from negative infinity to negative 7. My second yes is from negative 5 over 2 to a positive 5 over 2. Okay, question. What do you always put on your infinity? Excellent, parentheses. Now I just got to figure out what's going on these three numbers. Well, I don't see an equal to sign. So what do you put? Good, you put parentheses. And how do I keep these two sentences together? Good, the word or, right? Okay, how's that going? Good, hang in there. Got another example for you. Okay, so let's look at this fifth problem. Now, do you notice I'm dealing with a fraction? Okay, and the operation between the numerator and denominator is division, correct? Well, here's the great thing. Division is opposite of multiplication. So normally what works for multiplication is also going to work for division. Whatever process I used for multiplication, I'm going to be able to use for division. So here's the deal. Very important. Very important. Make note to yourself. When you're dealing with an inequality, you are not ever, I can't state this enough, you're not ever allowed to get rid of that denominator. Because if you get rid of this denominator, you actually get rid of a very important number. So never get rid of that denominator when you're dealing with an inequality. Got it? Okay, can't stress that enough. So here's the deal. In order to solve this, same thing. You want, sorry, didn't need that number, but you want this fraction to be equal to 0. Now here's the deal. Just like when we had multiplication in between our parentheses, we set each parenthesis equal to 0, didn't we? Well, we're going to do the same thing here. We're going to set this numerator equal to 0, and we're going to set this denominator equal to 0. This one's already solved. When you solve this one, you get 9, don't you? Now, this typically tells me my x-intercept, doesn't it? Well, here's the deal. I still have an x-intercept. My x-intercept is 0. But that 9, that's not an x-intercept. If I look back at the original problem, am I allowed to plug 9 in for the x? No, because if I do, I blow up the fraction, don't I? I blow up the denominator. Here's the deal. That 9 is not an x-intercept. That 9 is known as an asymptote. What does that mean? It means it's a wall that nothing can get past. Nothing can get through that wall. Okay? Let me show you what I mean. Since I found an x-intercept, since I found an asymptote, that means I can go straight to my graphing. I have negative infinity and positive infinity. I've got an x-intercept of 0. And now I've got this asymptote. I've got this wall. And yes, I change colors. Why? Because I need to make it very plain to myself that this 9, at this 9 is a wall, which means this side of the graph and this side of the graph can never get through the wall. They will come close, but they will never pass through the wall. Okay? Now, I'm going to do the same thing I've been doing. Let's pick some numbers. I'm going to pick a -1 from here. I'm going to pick a +1 from here, and I think I'll choose a 10 in there. So let's see if this works. You plug in -1 on the top, right? Let me just come down here and do the work. -1 on the top and a -1 minus 9. This top number is negative. This bottom number is also negative. What's a negative divided by a negative? Yeah, positive. Is a positive number less than 0? Nope, this ain't working. Let's look at the positive one. I plug in a +1 on top. I plug in the +1 on the bottom. On the top is a positive answer, on the bottom is a negative answer, isn't it? What's a positive divided by a negative? Yeah, negative. Is a negative less than 0? Yes, it is. So this second interval is working for me. Look at the last one. You plug in the 10 on top and the 10 on the bottom. I end up with a positive number on top and bottom. Is that going to be less than 0? Nope, that one's not working for us either. Are you with me? Okay, I only have one interval working for me, and that's this middle interval. That's the interval from 0 to 9. Got it? All right. So, what do I have to put around these? Yeah, no equal to sign means I put parentheses around both of them. Good? Are you with me? Cool. Hang in there. I got another problem for you. Okay, so let's look at this problem. Do you see there's not a 0 on that side? So here's the deal. I need that side to be a 0. Just like a couple of problems ago when we were dealing with the second degree equation, I need to have a 0 on one side. So I'm going to move this 1 to the other side. And when I move it to the other side, I need to add it, don't I? Agreed? Now, I've got a fraction and a non-fraction. The last problem was simple because it was a single fraction. I combined like terms on some of the previous problems. So this one, I need to have a single fraction, which means I'm going to have to add those two guys together before I can do anything else. So this has a denominator of 1. What would be my common denominator? Good, x minus 5, which means we're going to multiply top and bottom by x minus 5. Agreed? So here's what it's looking like. It's looking like a negative 4 over x minus 5 plus 1 times x minus 5 over x minus 5. Right? And that means I have negative 4 plus x minus 5 on the top, don't I? And an x minus 5 on the bottom. Agreed? All right. So, combining those like terms, it looks like I get x minus 9 on top, don't I? And x minus 5 on the bottom. This makes a very easy problem for me to work on, doesn't it? Now it becomes just as simple as that last problem we did, problem number 5. So here's the deal. First things first. You can't solve it with the inequality. You first solve like it has an equal to sign. And remember, never get rid of that denominator when it's an inequality. Never get rid of the denominator when it's an inequality. Okay, so I have an x-intercept. My x-intercept is coming from the x minus 9, isn't it? So my x-intercept is 9, isn't it? Whoops! Might help if I wrote that in the correct order, don't you think? Okay, so I should have written 9, 0. So let's try that again. Now, the x minus 5, since it's in the denominator, is that giving me an x-intercept? Nope, that's giving me an asymptote. Lovely. So, this x minus 5 still gets set to 0, and now I get x equaling to 0. Now I have a wall at x equaling 5. Cool? Okay, so we are going to see what we can do about getting just a little bit of board space, because we're going to need to do our graphing now, aren't we? Because I have an x-intercept and I have an asymptote. So I need to do some graphing. So let me clear a little bit of space here while you get space on your paper. And I'm sure you have plenty of space on your paper to do the work. Remember, make certain that when you do this graphing, that you put the numbers in the correct order. I have negative infinity and positive infinity. I have an x-intercept of 9, but now I've got this asymptote. I've got this wall at x equaling 5. Okay, Now, same deal. I'm going to plug in numbers and see what I get. I can plug them back to the original problem if I like, which means I could plug them back to here, or I can actually plug it into here where it is greater than or equal to 0. So I'm going to choose to plug them back into here because I think it's just going to be easier to deal with. I'm going to plug 0 in from the first interval, 6 from the second, 10 from the third one. So let's see when we plug in a 0. 0 minus 9 is a negative number. 0 minus 5 is a negative number. What's negative divided by negative? Yeah, that's a positive. Is positive greater than or equal to 0? It certainly is. So yay! Right off the bat I found an interval that worked. Cool? Now plug in the 6. 6 minus 9 is negative. 6 minus 5 is positive. What's a negative divided by a positive? Yeah, that's negative. That's not greater than 0. This one's not working for me. Plug in the 10. 10 minus 9 is positive. 10 minus 5 is also positive. Positive divided by a positive is positive. That's greater than or equal to 0. So here's another yes for us. So I've got 2 yes intervals. Good? All right. So one of them goes from negative infinity to 5. The other one goes from 9 to infinity, right? What do you always put on your infinities? Good, parentheses. Now take a look. The original problem has an equal to sign, doesn't it? Which means what do I put on here? Parentheses or brackets? Yeah, I'm supposed to put a bracket, aren't I? Except this wall says you can't use the 5, because if you use the 5, you get a 0 in the denominator and you blow up the fraction. So this dotted line trumps anything that the original problem told me. This guy's going to get a parenthesis. And then, yes, I need my union sign to keep my 2 sentences together. My answer is in this interval or it's in this interval. Remember, even though this said equal to, which told me put a bracket, this dotted line says no brackets, always a parenthesis, because your denominator would never, ever, ever, ever be allowed to be equal to 5. Because if it is a 5, I get a 0 in the denominator and I blow this whole thing up. Cool? Okay. Hopefully this made sense to you. You have fun with it, and I'll catch you on the flip side.